So welcome to RAS 215. We have finished chapter 2 that deals with forces. The entire statics revolves around these fundamental equations. Summation of forces is equal to 0 if a system is in static equilibrium. So we have studied summation of forces is equal to 0. Summation of moments about x, summation of moment about y, and summation of moment about z is equal to 0. These are called as the conditions of static equilibrium. In last class, I emphasized the importance of coordinate system. And in today's class, I will emphasize it again. So we are dealing maybe with a three-dimensional coordinate system. In three-dimensional coordinate system, you have x-axis, you have y-axis, and you have z-axis. So this is x, this is y, this is z. We talked about the concept of unit vector. Unit vector indicates direction but not magnitude. So unit vector in x direction is I, unit vector in y direction is j, and unit vector in z direction is k. So you have x, y, and x, y, and z, and respective unit vectors are i's, j's, and k's. Now the moments can also be expressed in terms of unit vectors. So this topic deals with moments. So we talked about what is a moment. Moment by definition, and I'm going to give you a vector definition, is r cross f. Now what is cross? If you have a vector A, you have a vector B, they interact with each other two ways. One thing is a dot product. When you have a dot product, you multiply magnitude of A, magnitude of B, multiplied by the cosine of angle theta. This is called as the dot product. Now, it is extremely important to understand A is a vector. It has magnitude and direction. B is also a vector. It has magnitude and direction. But dot product is a scalar quantity, which means it only has magnitude. Let me give you an example. If I say A is equal to 5i plus 3j and B is equal to 2i plus 1j. If I want to find out the dot product AB, if I want to find the dot product A dot B, I should write down 5i plus 3j multiplied by or dotted with 2i plus 1j. Now to solve this dot product, you have to expand. So you would say 5i times 2i plus 5i times 1j plus 3j times 2i and 3j times 1j. So I want you to understand what I've done here. A is a vector. The A vector is defined as 5 units in I direction, 3 units in J direction. So which means if I were to draw this vector, this is gonna be something like maybe 5 units here. So this would be the vector. Similarly, 2i and 1j. So you have another vector, maybe which is somewhere here. And if I want to find out the dot products of these two vectors, I take their individual components and multiply. So once you expand, this is what you get. Now I want you to look at each and every term very closely with the definition that is shown on the right hand side. So this is 5 times 2 and the cosine of angle in between these two vectors. 5 stands for the magnitude of the vector. I stands for the direction of the vector, or this is the unit vector. 2 stands for the magnitude of the vector. I stands for the direction of that vector. Product is going to be 5 times 2 multiplied by the cosine of angle in between these two vectors. Please understand I and I, so the angle between these two vectors is 0. You agree with me? So the product, first product is going to be 10 plus, same thing here, 5 times 1 is 5, but now you have to find out the vector, the angle of the vector between I and j, which is 90 degrees. So cosine 90 degrees is 0. So 5 times cosine 90. So this guy is 0 plus 3j times 2i. 3j times 2i is 6. Same thing, j and I are perpendicular to each other, cosine 90 degrees. And the last but not least is 3j times 1i is 3 cosine 0. Why cosine 0? Because j is aligned with j. So the answer of this dot product is nothing but 13. Everyone understood this? So other simpler way of looking at this vector is you perform something called as the matrix multiplication. You write these vectors something like this. If you use MATLAB, this is how it is done. And first row, first column gives you 5 times 2 plus 3 times 1, and answer is going to be 13. And it is extremely important. Why am I representing 5i, 3j is a horizontal or in the row format with 2 i's and 1 j in sort of a column format, because I'm trying to find out a product or a multiplication of these two vectors. Now, with this in mind, let's move on to the cross product. So if you have a vector A and if you want to cross it with vector B, A cross B is going to be magnitude of A, magnitude of B multiplied by the sine of angle in between. Now please try to understand, dot product does not have a unit, which means it's only has amplitude, only amplitude. It's a scalar. So please note, there is no unit vector associated with dot product. However, cross product is a vector product, and you will have a unit that is associated with a cross product. Now, before I solve this complicated problem, I want to take a simple problem. Now, let me give you A is equal to 3i and B is equal to 2j. And I'll work out the complicated problem, but I just, for the sake of initial simplicity. So what you have is you have one vector, which is 3i, and then you have another vector, which is 2j. 3i and 2j. I have these two vectors. 3i is my vector A, 2j is my vector B. Now, if I want to perform the cross product, and I'm going to write it over here, the way I would do it is magnitude of A. Magnitude of A is 2. Magnitude of B, magnitude of A is 3. This is A, and this is B. Magnitude of, and please note the order is very important. Magnitude of A is 3, magnitude of B is 2, and the sine of the angle in between is sine 90 degrees. Now, it is very important that I want you to understand is this is X, this is Y, and you have this Z. So what's happening here? What is happening here is I can represent this vector. So whenever you have a cross product, it is, you can translate this vector along the vector. You can actually translate the second vector along the first vector. So I can rewrite, or I can show this something like X 3i two j, and I need to find out the cross product of I and j. So multiplied by here, it would be I cross j. And I cross j is nothing but k. So the answer is going to be 6k. And I'm going to explain this one more time because this is actually a very profound expression that I want to understand. Dot product is a scalar product. It does not have direction. Cross product is a vector product. It means in addition to the magnitude, it needs to have a unit vector associated with it. Now, I want you to look at the answer that I have got. I got I cross j is equal to k. So I have this vector 6 in k direction. But if you think about it, what this essentially is you have a radius, you have a force. So this product is giving me a moment. This product is giving me a moment. And I want to find out what is the direction of this movement. I want to find out what is the direction of this movement. And you can see, if I see, this is my, I'm going to call this R, and I'm going to call this F. So this is nothing but R cross F. So this is giving me a moment, and this moment is about k axis. And this moment about k axis This is my K. If you curl your fingers in the direction of the moment, can you see that your thumb is pointing towards the positive Z axis? Can you see that this 6K has a positive sign? In other words, cross product represents moment of a force. If you have a vector A that is crossed with vector B, by definition of cross product, you have A, B, sine theta. Cross product needs to have a unit vector associated with it. To find the unit vector, you do the crossing I cross J, and I cross J is nothing but K. Now I just said that. Now I'm going to explain to you in one more way, and then we will solve the two-dimensional problem. So let me tell you once again, cross product is A cross B. It's a cross product. It's a vector product. Which means it has the magnitude and it has direction. So now, if I give you a vector, something like this, and I'm going to call this the radius vector. And if there is a force acting on the radius, so if this radius vector is 3I and the force vector is 2J, if I want to find out the moment, moment is given as R cross F. R is a vector, F is a vector. And to write this, M is equal to 3I cross 2J. 3I cross 2J is nothing but 3 times 2 is 6. In the parentheses, I cross J. Now we are dealing with triad. So remember this called circle of vectors. And I want you to remember this because this will be useful wherever you go. As long as you are a roboticist, this circle of vector is going to be useful to you. So you have 3 unit vectors. You are dealing with a triad. You have 3 unit vectors. You have I, J, and K. Now please note I cross J is K. I cross J is K. J cross K is I. Can someone tell me what would be K cross I? J. As long as you are going in the clockwise direction, the cross product gives you the next vector. Imagine if you were to do just the opposite. If you do J cross I, if you do J cross I, you are going in the opposite direction, you get minus K. If you do K cross J, you are going to get minus I. You do I cross K, you're going to get minus J. So remember, in cross product, order is very important. If you are going in the same direction as circle of vectors, I cross J is K, J cross K is I, K cross I is J. If you go in the opposite direction, this is what you get. Now looking at the equation that I have written over here, what is I cross J? I cross J is K. You agree with me? I cross J is K. Now what I'm going to do is, just for the sake of discussion, I'm going to add the coordinate system. I'm gonna add a coordinate system. This is my y. This is my y. This is my x. Y has j, x has I, and then I have this triad, which is z, and this is k. Now tell me, looking at the direction of the force and the movement, the force is going in the upward direction. It is perpendicular to the radius. Can you see that this force is gonna give us a moment in this direction? You agree with me? This force is going to rotate about z, and this rotation is going to be counterclockwise. Now, when you curl your fingers in the direction of the movement, can you see that your thumb is pointing towards the positive z-axis? And what that means is the resultant moment that you are getting is positive. Everyone understood this? So remember, if you want to find the moment, you can use the radius multiplied by the force. If you want to use the vectorial representation, you can use the cross product. Now, let me solve the problem that we started with. So problem is something like this. I have a vector r. And that vector r is 5 plus 5i plus 3j. 5i, and this is a very important problem. So 5i plus 3j. And I have a vector f. And this vector is 2i plus 1j. 2i plus 1j. So this guy is the radius, and this guy is the force. Now what I want to do is, I want to find out the cross product, or in other words, I want to find out the moment. So this is going to be the moment. Always remember, moment vectorial representation is always going to be R cross F, never F cross R. Because cross products are non-commutative. You cannot change the sequence. It always has to be the radius crossed with the force. And I'm going to explain this problem. I will explain this geometrically, and then I will explain the same problem using algebra or vector representation. Let me first draw the coordinate system. Let me first draw the coordinate system. This is x. This is y. So this is 1, 2, 3, 4, 5. So this is 5i. And then I have 3j. 1, 2, 3. So 5i and 3j. This is the point. This is 5i, 5, 3. And I'm going to draw this vector. This vector is my r, which is 5i plus 3j. Are you with me? Now I have one more vector. This vector is 2i plus 1j. So I have another vector, 2i and 1j. So this is my 2i. It's very difficult to draw here, but I'll try to draw it over here. 2i, 2 and 1. So my force vector F is equal to 2I plus 1G. Now I want to find out, here is the problem that I'm trying to solve. My radius is shown as 5I times 3J, and my force is given as 2I plus 1J. Radius unit. Now it's very important to understand. Radius unit could be in meters, could be in millimeters, could be in centimeters. The force unit could be in pounds or newtons or kilonewtons. So at the end of the day, when I do the cross product, the result M would have the unit of R multiplied by the unit of S. In other words, R and S will not have the same unit. The product will take the unit derived from those individual vectors. Everyone understood this? My R, which is the radius, is in meters. My force F is in newtons. Now, if I want to find out, so what exactly is happening? And I want to show you over here. So I have this radius. I have this radius. And this force, it's somewhere here. So I have this radius. I have this R vector. And then I have this force vector F. And I want to find out the moment. I want to find out the moment given by these two vectors. Everyone understood this? Now, if you just look at the way these two are expressed, you may say, oh, it's kind of difficult, no? Because I have this vector over here. I have this vector over here. How do I solve this problem? But if you look at it, what I can do is, I have this vector R. I can represent this into this consistent coordinate system. I can represent this into the consistent coordinate system I, and I can represent this in a consistent coordinate system J. In other words, I can resolve the vector R along I, and I can resolve the vector J, R along J. Do you agree with me? So if I were to resolve my vector R, do you agree with me? Vector R would have a horizontal component and vector R would have a vertical component. Do you agree with me? So I'm going to call this Rxi. Rxi is component of R in the X direction. And I'm going to call this Ryj. Do you agree with me? Which is the component of R in J direction. Please note, this vector is going towards right. This vector is going up. So the final resultant should close this vector. Everyone understood this? This vector R is resolved into its X component and its Y component. Everyone understood this? And why am I doing this? Because please try to understand. You are trying to find out the summation of $10.05 and 100 rupees and 30 paisa. These units, so you are trying to manipulate a universe. You are trying to manipulate these two. You cannot solve dollars to pesos problem. You need to express both of them into consistent unit. Only then you can perform any type of addition, multiplication, or that stuff. So I have this vector. I represented this vector as a component in I. I represented this vector as a component in J. I'm going to do the exact same thing for the force. So for the force, I'm going to have a horizontal component and I'm going to have a vertical component. Horizontal component is going to be Fx of I and vertical component is going to be Fy of J. Do you agree with me? So I have these two forces which are arbitrarily oriented. What I did, I resolved those forces along I or X and in Y. Can someone tell me now what is the advantage of doing this? Now the advantage of doing this is I want you to note, please note, this radius is perpendicular to this force. Can you see? Rxi is perpendicular to Fyj, which means I can write down the expression for the moment that is given by Fyj is Rx times Fy. I need to draw this further. So, but please try to understand what I have now is I have this force, and I have resolved these two forces. I have resolved this radius. So now I have Rx, Fy, and I have Ry, Fx. Are you with me? So Rx is perpendicular to Fy, Ry is perpendicular to Fx. Do you agree with me? Definition of moment is force multiplied by the perpendicular distance. So now when I resolve this vector into its x component and y component, I resolve this force into its x component and y component, I can clearly see that the moment given by these forces is the product of radius in x multiplied by force in y and radius in y multiplied by the force in x. Do you agree with me? Can you see this clearly? But what is the problem? The problem here is, if you look at the moment given by Fx about this point, moment given by Fx about the origin, this moment is clockwise. This is the moment Fx Rx, Fx Ry. I'll write this just to be consistent. This is going to be Rx, no, Ry, it's going to be Ry, Fx. And then you have this another moment which is given by Fx, Fy. So this would be Rx, Fy. Rx, Fy. So now can you see that these two forces are giving you the moment, but one moment is clockwise and other moment is counterclockwise. Do you agree with me? If you curl your fingers in the direction of moment, you would notice Ryfx is positive, and Rxfy is negative. Talk about this problem again in different ways, but I want you to understand, if I give you two vectors, if I want you to find the moment, you can find out the moment given by the vectors by resolving the vectors into its subcomponents, finding the product and assigning the sign. The other way to solve this problem is, I'll show you, is you have R, which is 5i plus 3j, F 2i plus 1j. You can find out the moment. Moment is equal to R cross F. You will write R is equal to 5i plus 3j cross 2i plus 1j. Expand. 5 times 2 is 10. In the parentheses, I cross I plus 5 times 1 in the parentheses, I cross j plus 3 times 2 j cross I plus 3 times 1 j cross j. Are you with me so far? What I've done is your radius is 5i plus 3j. Your force is 2i plus 1j. I plugged in those numbers and just expanded that bracket. Expanded that parenthesis. Everyone understood this? Now let's look at the circle of vectors. If you look at the circle of vectors, you have I, you have J, and you have K. Please note, cross product means magnitude of the vector multiplied by the sine of angle between those two vectors. So can you tell me what is I cross I? 0. Why? Because the angle is 0. The sine of 0 is 0. So I cross I is 0. What is J cross J? What is J cross J? 0. Do you agree with me? Now I want you to pay attention to 5 times 1 I cross J. What is it? 5 I cross J? Positive K. Do you agree with me? Now what you have is J cross I. What is it? Negative K, right? So which means your resulting moment is minus 1K. Do you agree with me? Which means when you look at, now I want you to do the exact same thing with the problem that we have represented in the previous slide. Everyone understood? I solved this problem vectorially and I got minus 1K. What does it mean? Minus 1K means that my moment is like this. Do you agree with me? Because curl your fingers in the direction of the moment and my thumb is pointing towards the negative K axis. Can you see that? Minus 1K means curl your fingers in the direction of movement. Thumb is going towards the negative Z axis. Which means this is how the moment is represented. Everyone understood this? Now what I want you to do is, I want you to go back to the previous slide and just substitute the numbers. What is the value of Ry? What is the value of Ry? Ry is 3. What is the value of Fx? This is Rx. This is Ry. This is Fx. This is Fy. What is the value of Fx? Fx is Ry is 3. Fx Ry. So R 5 times 1. So 5 times 1 minus 3 times 2. the answer you are gonna get is -1. So ry, and fy, and then ry and fy, correct. This is ry and f. So this is minus. No, this is positive, and this is minus. So do you get -1? So whenever you solve by both these methods, you are gonna get the exact same answer. Let me take one more example. Imagine that you have a beam, something like this. And on this beam, you have a force which is at 30 degrees. And this distance is 5 meters. You can solve this problem multiple ways. Let's start the simple way. You have this force 10 newtons. I'm going to resolve this force horizontally, and I'm going to resolve this force vertically. Horizontally, it's going to be 10 cosine 30. Vertically, it's going to be 10 sine 30. Now, if I, yeah, 345, right? We should open at 345. And I'll finish this problem in next 1 minute. So can you see that you have this horizontal component, f of x, and you have this vertical component, f of y, and your lever arm or the radius is 5. So the horizontal force, 10 cosine 30, is not going to give us any moment, but the vertical force is going to give us a moment. So the moment is going to be 5 multiplied by 10 sine 30. And this moment would be in this direction. So this will be clockwise moment, Newton meter. So 50 sine 30, which is 25 Newton meter. Now I want to solve this exact same problem using my vectorial representation. So my r is going to be, this is my 0, this is my x, this is my y. So r can be represented as 5i. Force can be represented as 10 cosine 30i plus 10 sine 30j and then what you can do is you can do the cross product, and then you should be able to find out the same answer. And with that, I'm going to stop here because now you are due for a quiz. So